Hi, I am Paul. I'm a maths tutor, live in London, and yeah, I do mainly A level and some GCSE. So, what I'm going to do is because I am struggling with boredom and wanting to pass on my wisdom to the youth, or maybe not the youth, a variety of age, whatever age you might be, I'm going to do some live streaming of maths. And I'm going to do it every day during the week. But just so I'll start from next week, from Monday. For now, I just wanted to set up a little video to get you a feel of what we're going to do, and hopefully you can join me next week. 20 minutes, 30 minutes, just a couple of questions, just to keep us going in these kind of difficult times. But even if, you know, we come across this later, it doesn't have to be because of the difficult times. I think it's just nice to get in there with a few exam questions and work through it and get a feel for how you're going to go about it. Because, okay, we don't have the exams now, right? We're not having to sit the A level exams or GCSE, but ultimately, if you're going to go on to university or whatever situation you're going to find yourself where it's maths that you're doing, you're going to be sitting an exam. There's not really coursework stuff for maths. It's not like politics or history. So that's why, I might at some point do some videos of different topics of differentiation or radians or sequences, whatever. But really, for now, I just wanted to just be chilled. Let's all relax. Calm down, calm down. We're just going to do a couple of questions a day, 2 or 3. All right, and exam style questions. If something comes up that particularly I get excited about, I may, chat more about it, but I'm not going in with any agenda. I'm just going in, and well, the ones I'm starting with, anyway, are edXL, and it's the new edXL syllabus specification. And I'm doing it from 2018 to begin with. That's the first. That's the first time they used the new specification. So let's just do a couple of questions from that for today. All right, and yeah, I can I'll maybe check other exam boards at different points, or I'll decide how I feel. But we're going to go with this for now, and I think let's just get started. Enough of me banging on. So yeah, I just kind of and there's no theme running through. If there's any theme, it's that I want to cover a bit of everything and make sure that everything remains fresh. I don't want to focus too much on one area and then other areas stop being focused on. So we're going for it. First up, selected this one. So this is an integration question, clearly. Let's just sort this out. Cool. Yeah, so, okay, you're going to need a bit of prior knowledge here, I guess. First thing is just a little bit of chit-chat. Let's be absolutely clear what's going on. Maybe I'll write it out first and then chat about it. Oh, I've drawn a kind of a funny Z there. It's a bit worrying. Let's exterminate that part of it. And I'm just doing part A. Firstly, now already this has given you a flavour of the new A-level specifications, that it's not just a standard integration anymore. They love to sneak in this this K, these numbers, these constants, absolutely loving it. They're not just saying integrate 2 over 3x minus 1 between 1 and 10. They want this K thing, and they're asking us, they're saying is it's independent of K. Well, okay, we might have some idea what that means, we might not, but anyway, we'll get into that. First thing I wanted to just really get into is what does this mean? What does this mean? K, some sort of little liney thing, looks like an E, Z plus. First thing, that is real numbers. And real numbers can be absolutely anything. It's the broadest category. So it could be like -4, -3.6, 0, 1, a half, pi, anything. So it can be negative, it can be 0, it can be positive. Then you've got integers, which is what the z is, integers. That's got to be a whole number. So it's going to be -4, -3, 0, 1, 10. It can be 0, and it can be negative. But it has to be a whole number. It can't be a third, it can't be 2/6, it can't be pi. Well, 2/6 is a third. So, okay, so that's those. Now, that sign with a z plus sometimes has another name, or it can also be called n, you sometimes see it as, which means natural numbers, and it basically means the positive integers. So that's why I find that people don't always have a clear grasp of this, so it's good to just get up to speed with it if you can. Real numbers is anything, negative, decimals, 0, pretty much everything. Integers, whole number, can be negative and 0, and positive integer, 1, 2, 3 and beyond, positive whole numbers. So anyway, you were saying k is a positive whole number. May or may not be any great relevance in that. We'll see when it comes. We'll see if that's important or not when it comes to the end. Usually, there's going to be limits put on that for different reasons. I don't know. They've said it's got to be positive. Is there going to be some issue where you're having a square root of a negative? Is there going to be some issue where your thing on the bottom goes to 0? These are the reasons why they might limit what they're telling you to put into the question. Okay, enough bleating on. Let's actually try it. So that was kind of setting it up. Now, the next thing you need to know is how to actually integrate this thing. That would help. Now, well, it's not really a spoiler alert, but it's a mild spoiler, is that, and it's kind of something you just need to remember and know about your life, the integral of 1/x is the natural log of x. So really, everything in this question is going to spring up from there. All right. Works the other way around as well. If y equals ln x, then the derivative of dy of ln x, the natural log of x, is 1/x. So I don't want to get into too much, what natural log is and all that kind of thing. Now I will never shut up if I get started on that. It's just you need to know these identities. The integral of 1/x is natural log x, and derivative of ln x. So, and similarly, you can start using that. Let's say you had something like y equals, well, I'm getting heavily distracted here, but this can and frequently does happen. So let's just say what we're going to go for. If you had 4, let's just test it, 4 log 2x plus 6. All right. This is a testing. I want to differentiate it and see what comes out. Now, well, you differentiate that. How are you going to do it? This is where it might be good if I came in and did, let's cover all the different ways to differentiate. Let's cover all the rules. Let's cover chain rule, product rule, quotient rule. But we're not going to do that just yet. Instead, I'm just going to tell you this is chain rule. You've got a bigger function, which is the natural log, and within it, you've got a smaller function, which is 2x plus 6. Now, you could just do this kind of shorthand quickly as well, but I feel like that's not what we're wanting. We're wanting to just let's do a proper chain rule. And the proper chain rule says that dy by dx equals dy by du times du by dx. Cool. Now, what on earth does that mean, might you say? Well, what we're saying is if you call the bit inside the ln, if you call that u, i.e. u equals 2x plus 4, okay, u, then you can rewrite it as y equals 4 ln u. So yeah, I've not done anything absolutely drastic. All I've done is said instead of writing 2x plus 6, I'm going to call that u, and then I can rewrite it like that. I feel like that could be worth a box around it. Chain rule. Yeah, so, and the chain rule says if I want the derivative of this top thing, all I need to do is differentiate that, because you'll get dy by du, and then multiply by the derivative of that, which is du by dx. So, dy by dx equals, so the dy by du, right, differentiating this. Now, this is where you need to use our little rule of the derivative of log, or derivative of ln x is 1 over x. So derivative of 4 ln u is 4 over u. That's how it works with the numbers, by the way. You just need to get used to that a little bit. If it's 4 times something, number stays at the top, as it happens. All right, so that's dy by du. And now du by dx is just 2. If we differentiate that, 6 goes away and you're just left with 2. So dy by du is 4 over u, du by dx is 2. Multiply them together and you get 8 over u. And u, well, we know that from our substitution, was 2x plus 6. So really, that's what you're getting with chain rule. And I would always, I know you're going to be stressed in the exam, there's time limits, there's pressure. You might want to do quick, someone might just say, oh, take that to the bottom and multiply by the derivative of what's in here. I don't know, there's quick ways you can get through a chain rule. But ultimately, I would always like to see it done like this. I just don't think twice. I write that out. dy by dx is dy by du times du by dx. Find out what your u is, go through it all like this. Anyway, why did I start banging on about this? Well, I just wanted to show you that the derivative of that is this. So there you go. You've got a structure, this 2x plus 6 at the bottom, and just a number at the top. All right. Now, how does that apply to our question? Oh, would you look at that? Very similar. Number on the top, and then something with an x, and then another number on the bottom. So it's just something to look for. That if it's got this format, where there's just x's on the bottom, the integral is going to be a log. So, yeah, what I would basically do with it then is, with that in mind, let's just go for it. And yeah, okay. Speaking too much, I think we should just actually do the action. So I'm going to write it out again, and then do it. So it's going to equal, so this is after I've integrated it, 2 times log, natural log, 3x minus k. But you also need to divide by the derivative of what's in here. So it should work like that. And we could again try chain rule and make sure that worked out 2/3 time that. I'm not going to do it now, okay? But you need to get a bit of a feel for it. And actually what they call this form of integrating, there's a chapter on it in the EdXL textbook anyway, is reverse chain rule. It's integrating by reverse chain rule. You got to look at that. You got to think, goodness gracious me, that looks like it's a log differentiated. Therefore, it's going to have this kind of structure with the 2 at the front, and then all you need to do is kind of find what this number is, or the sum maybe have to divide by 3 or times by something, just to get it all working correctly. And there's a little bit of an art to that and playing around with it, but there you go, that's what it's called. Anyway, however we did it, that's the integral, and so now we just need to plug it in. By the way, I've not even really got to answering the question yet. It's saying, show that it's independent of k. Well, I feel like we're going to just go through it till the end, and then hopefully we'll see what being independent of k means. Cool. Right. Anyway, first thing, I'm going to keep that 2/3 there, and I'm going to plug in the 3k. So 2 over 3 ln of 3 times 3k minus k. Okay, that's plugged that in. Minus 2/3 ln of 3 times k minus k. Next line, not much paper left here. 2/3, so that'll be 9k. Yep, cool. So it's going to look something like that. Now we'll go into a new bit of paper. And I'll just write that again on the top. I could even maybe do it like this. Cool. So what have we got? Yeah. 2/3 ln 8k minus 2/3 ln 2k. Okay, and this is kind of why I like doing the exam questions, because now, you know, what did we start with? We started with this integration question. I've told you about real numbers, integers, positive integers, natural numbers. Then we've talked about identities. Derivative of natural log x is 1 over x. Integral of 1 over x is natural log of x. It works backwards. Then we snuck in chain rule, just to make sure we know what that is from differentiation. Reverse chain rule, and now, lo and behold, we're ending up needing to know the log rules. We're needing to know how logs work. So just put a little bracket, just like a bracket there. Sometimes you see an absolute value sign. All right, I quite like a bracket myself. I'm not really let's not get into the detail of that. So there's no two ways about it, and this works for any log. By the way, you know, log to the base e is ln. That's what that natural log is. It's just log to the base e. Confusing topic generally, logs, so let's not get bogged down in it. But right, okay, log of AB is the same as log A plus log B. Is a rule. It's a log rule. Then it is a log rule. Cool, so yeah, if you've got two things multiplied inside the brackets, bring them out. And that's with any base, so I could call that log base C, just to really bring the point home. Whatever the base is, as long as it's the same. And like I say, natural log is just another way of writing log to the base E. So anyway, now I might just start going a little bit quick with that, now that we have that rule. So it'll be the equivalent of ln 2/3 8 plus, sorry, 2/3 ln 8 plus 2/3 ln k minus 2/3 ln 2 plus 2/3 ln k. That's using that log rule. Splitting up the 8 and k and 2k into 2 parts each, using that rule. Cool, now that minus is going to make these both minus. So that minus that, they're the same, they're going to cancel. Oh, look what just happened. They're the only terms that had k in them. And they just went. That minus that. Gone. Independent of k. Well, there's no k's left. Okay, but let's just calm down everyone and get this finished before I start explaining that more if necessary. So that's what we're left with. We could just polish that up a bit. 2/3 bracket ln 8 minus ln 2 which is 2/3 ln 8 over 2, which is 2/3 ln 4, right? By the way, this rule is the complementary one of this one. You know, the rule is if you've got like log of 6 minus log 3, that's the same as log of 6 over 3. That one I put in general letters there, but sometimes people get confused with general letters and think it's a little bit funky, so let's just get the numbers in, you know. If you've got some two logs like that, again, the same base, sometimes I don't write the base, that's a whole, anyway, not getting into that, that's how it works, right? That's an identity. It's the spiritual equivalent of that, the rule with where you multiply two things. It's the same as splitting them up and adding them. Anyway, one way or another we got to here, and so that's your final result, really. You don't really need to simplify that much more. I think you're done. And there's no k's in it, so that is what they meant when it's independent of k. So I guess what they've said is, we start with this. It's got k in the two bounds, in the lower bound and the upper bound. They've got k's in it, and there's a k in the same blooming thing on the bottom in the denominator. Yet, when you integrate it, you get an answer with no k's in it. So that means you could have done 2 on the bottom and 6 on the top. If you did k is 2, and then you could have put in 2 here, you would have got that same result. You could have said k is 6, you could have put 6 here, and 18 on the top, and stuck 6 here. You'd have got the same result with the integral. So that is what they are really all about in that question. Okay, chatting too much. Let's get on to B. And we might end up just finishing, you know, this is sometimes what happens to me when I'm doing my tutoring sessions. I don't know, you just start doing something and you get involved in about 6 different other areas. Time passes. I mean, we're already on to what, 22 minutes here. But yeah, that's how it goes. B. Maybe try and do this one a little bit more quickly because we're already banged on about all the log rules and stuff like that. So this one, although that said, it doesn't look like a log, this one. It doesn't look like a log. Should really write the dx in there. They're saying it's got to be inversely proportional to k, the integral. So let's just do it. Now, this time, on the bottom, there's this squared. Didn't have that last time, and the log stuff that we did last time in the previous question, with that chain rule, for example, you know, it was all reliant on the result just being like something with x, and there's no power here. So as it happens, that's the only, it doesn't extend, all right? The log, it's not going to be a log integral this time. This time you're still thinking, what are we going to have to differentiate that gives us this? But it's not a log integral. And actually, this one's easier. It's only 3 marks as well, so let's just do it quickly. If you've got, if you've got some power on the bottom that's not 1, that's not the, like the one in part A, then you bring it to the top, make it a minus power using your indices rules and integrate it like that. Integrate it like a normal kind of entry-level primary school integration. Okay, primary schools. A little bit of an exaggeration, but you're going to do the old chestnut of add 1 to the power, so you get to minus 1, and then divide it through by the new power. Alright? And for your final act, you also have to divide it through by the derivative of what's in here. Derivative of 2x minus k is 2. K goes away. So you also have to divide it by a 2 on the bottom like that. Between k and 2k. Just tidy that up a little bit. That'll be actually just be minus 1 then. 2 over 2 times minus 1, just a minus 1 on the top. 2x minus k to the minus 1 between 2k and k. Let's just even tidy that up a little bit more. I wouldn't usually maybe spend this long doing it, but it looks nice, probably like that. This bracket is unduly small, should be that size. Again, indices rules, something to the power minus 1 is like 1 over that thing. Okay, and now I'm doing my plugging in my bounds, top and bottom, minus 1 over. Now that'll be 4k minus k, minus 1 over 2k minus k. So you're going to have 1 over 3k plus 1 over k. Take a trip back to your 11 plus exams, which you absolutely loved when you were younger. If you were in England or other parts of the world, whatever you were doing, you were putting fractions together and having a great time with it. Doesn't stop here then. Cross multiplying, that's the same as 3k over 3 over 3k times top and bottom by 3. And so that's going to go to 2 over 3k, which is, well, so it's proportional to 1 over k, which is inversely proportional. So let's just absolutely cement that home and check that you're happy with what that means from GCSE knowledge, that if, you know, something, so if y, you know, is proportional to 1 over k, for example, maybe that's a bit confusing, maybe we should call it x, because the k sneaks in GCSE language. Anyway, this kind of chat means y is inversely proportional to x. That means it's related as 1 over that thing. Well, that's what we got here. We've got that. Our integral, that's what we were integrating. We did it. We plugged in our k's as the top and bottom. We were probably a bit stressed because they weren't a number, because usually we like to have these as actual numbers, like 1 and 20 or pi and 2 pi. We didn't get that today. We were not offered that luxury. Instead, we put in the k's, did all the stuff, did algebra, and this is what the integral gave us. And it's 2 over 3k, the k's on the bottom, and that is an inverse relationship. It's something over k. So, indeed, the integral is inversely proportional to k, as required. You might want to write, you could write a line or something in there if you wanted to drill home the point in an exam, but I'm not so worried about that. I'm more interested in the concept of, can you start from the top, get through that integration accurately with the boundaries, and come up with your answer, which is inversely proportional to k. So I'm not going to do any more questions, to be honest, because this is what you just dream of doing 4 or 5 or something like that, but you just get bogged down in, it's not really, maybe bogged down is not the right word, you get distracted by other little nuggets of joy left, right and centre. Let's do a mild recap though, okay? And then we're done. Yeah, it's a good question actually of, did it matter? Why did it matter? Why were they even telling us that k had to be a positive whole number? Good question. I never really, it's not totally obvious why that's true. I still can't see why that mattered. I mean, the integral we got out was 2 over 3k for that last question. Well, that doesn't seem to really matter if k is positive or negative or a real number. I'm sure there's some reason. Maybe that can be your homework. It's always a good tactic, isn't it? If you don't know the answers, punt out as homework. So I'm happy to. Anyway, it was useful anyway, but give us a recap. Real numbers are all numbers, decimals, negative, 0, positive, fractions, pi, e, the lot. This little thing, the z is for integers, negative whole numbers, 0, positive whole numbers. Z with a plus on it means positive integers. So it's like the one at the top, but you get rid of all that, and you just got 1, 2, 3, 4, all the way to as big as you can count, also known as natural numbers. Same thing. Okie doke. And then, yeah, little things. Derivative of ln x is 1 over x. And going backwards, the integral of 1 over x is ln x. I think that one deserves a box as well. Probably. Got to be fair. Got to be fair in this world. Chain rule. dy by dx is dy by du times du by dx. Just write it. You just whenever you think chain rule, that's going down. And it's not that hard to remember because it's like those du's cancelling out and you're just left with dy over dx, and it's like that. You could kind of imagine cancelling them. Anyway, not hard. Then there's a little bit of an art in choosing the u. I'll grant you that. It's not always totally easy to choose it. Here we go. And by the way, why do you think... No, okay, no. I could get into it. Maybe this is something for next time, but how did I know to do chain rule? That might be something you would ask. How do I know it's not a different way of integrating? The answer, the spoiler alert, is if it's a function of a function. This is a function 2x plus 6 is inside another function, which is the natural log. More on that at a different time, perhaps. So anyway, that's the chain rule. So you can rewrite y as that, u as that, differentiate them both and multiply them together, and it's done. Doing that, having done that a few times, you'll start to realize there's a pattern. If you differentiate logs, or natural logs, they come out kind of like that. Therefore, if you have to integrate something that looks like that, it is going to end up as a natural log. Because you're going backwards, you need to do a quick adjustment for the number at the front. Watch for that. Anyway, it's between 3k and k. Plug the stuff in. That's fairly reasonable. And I guess the only other thing that crops up is your log rules. Worth revising, worth getting on top of. There are other log rules I didn't mention today. This is the only one I did, and it's spiritual partner, which is this. But once you're equipped with that, you can follow through the working. You notice that the k's cancelled here, the thing with k in it, and so there was no k's left in our answer. It was independent of k. Then b looks like a similar structure. Difference is that power of 2. Therefore, the integral is not a log. And actually, in fact, one mark easier, it's just, maybe it's a little bit blasé to call it classic integration, but this is early stages of what you think of as integration is add 1 to the power, divide by the new power, and then you also need to divide by the derivative of what's in here to balance that out. Plug in the two k's and k's, you end up with this. Bring it together in some sort of primary school manner. Common denominator looks like that, which is proportional, inversely proportional to k. Happy days. Thanks, guys. So yeah, I'm going to keep at this. I'm going to start doing it live from next week. I'll keep you updated on what the times of that's going to be. And if there's one person here or no people here, that's fine. I'm getting out anyway. You can come and look at it later. You can give me requests if there's anything you want me to do. We'll see how it goes. But the most important thing is let's get in there. Let's keep on top of it. It's so easy to become lazy and tired of all this, just being in the house all day. Let's get in there and focus our minds on some of this stuff. Not in a kind of stressful way. We're not stressing each other out in a chilled out way. Let's get through some of these hard maths questions. It's good for the brain, good for the soul, and it'll keep you ticking over and get you ready for university actually as well, because your first year uni courses are probably going to have integration, differentiation, this kind of stuff in it. Okay, thanks guys. Bye for now.